The next question is matrix matching type. In column 1, we are given starting materials and the reagent and the product as A, B, C, D. And here we are given P, Q, R, S, T. So you're asked in column 2, the nature of the reaction. Is it oxidation reaction among ABCD, which are oxidation reactions, among ABCD, which are condensation reactions, resulting in nucleophilic addition reaction? Reactant can give positive iodoform test, not about the product, and nucleophilic substitution. So is it nucleophilic substitution reaction? Is it nucleophilic addition? Is it oxidation, condensation, or which of the ABCD reactions the reactant can give iodoform test? So when we go for the first reaction here, this is acetaldehyde and two molecules of acetaldehyde in the presence of a base, aldol condensation. So therefore it goes with condensation Q. Then nucleophilic addition. In the mechanism of aldol condensation, if you can recall, what do you find? OH minus will first of all attack alpha hydrogen and carbonyl is formed. Carbonyl attacks the other aldehyde molecule and therefore it is nucleophilic addition. So therefore nucleophilic addition is R. So it also goes with R. Then reactant can give positive iodoform test. It is acetaldehyde. There is a methyl group here. Methyl group directly attached to carbonyl carbon is the one that gives positive iodoform test, even it goes with S. So the answer is Q or S. Then when we go for the second one, it is a formaldehyde. In the presence of OH minus, in fact strong base, it is giving HCO minus for mate ion and methyl alcohol. It is one example of a reaction which is known as Canniger-Rouse reaction. And Canniger-Rouse reaction involves what? Simultaneous oxidation reduction. So therefore oxidation is there. So it goes with P. And therefore it does not go with condensation. And in this Canniger-Rouse reaction, if you can recall the mechanism, there is a hydride transfer which will attack the carbon of the other aldehyde. And therefore it is also nucleophilic addition. And then we have formaldehyde does not give positive iodoform test. Therefore S is not correct. Nucleophilic substitution. There is a shift of proton to give this carboxylic cation where more stable than methoxide ion. And thereby there is a substitution possible. Hence it is PRT. So here 2 moles of benzaldehyde is treated with KCN to give the product. And benzaldehyde when treated with the KCN, it's a specific reagent, alcoholic potassium cyanide, in the presence of which benzaldehyde undergoes benzoin condensation. So it goes with Q. And in the benzoin condensation, nucleophilic attack on the carbonyl carbon will be there in the mechanism when you observe. So therefore it is the nucleophilic addition. And this reactant benzaldehyde does not give iodoform reaction and there is no nucleophilic substitution involved. So therefore it goes only with QR. And when you go for, this is acetone, CH3 twice, C double bond O, I2OH minus product. And it is the one with methyl group directly being attached to carbonyl group. It gives iodoform test. So therefore it goes with S. But what about OH minus attack on the carbonyl oxygen? What about the OH minus attack on the carbonyl carbon? Delete the previous statement. So therefore nucleophilic addition also takes place. And at the end in the reaction you find nucleophilic substitution to occur. So it goes with T also. And in the first case you are familiar with aldol condensation. So when we take 2 moles of acetaldehyde in the presence of a base OH minus, we get an aldol CH3, CHOH, H2, CHO, 3-hydroxybutanol. This can lose a water molecule and give unsaturated carbonyl compound cotonaldehyde CH3CH double bond CH CHO. This is the final product and this methyl group is responsible for iodoform test. So this is condensation reaction. Therefore Q is the answer for this. Then what about nucleophilic addition? If you can go through the mechanism of this reaction, you will understand that the carbanion CH2 minus CHO, which is formed when OH minus attacks the alpha hydrogen, will attack another molecule of acetaldehyde. So this will go and attack here. So thus nucleophilic addition, and this is nucleophilic addition. So therefore the A goes with R also. Then we have taken S also the answer for it, because methyl group being attached, it gives the iodoform reaction as you know. And for B, where formaldehyde is there. 2 moles of formaldehyde in the presence of strong base 50% KOH, and on heating simultaneous oxidation reduction takes place to give one molecule of methyl alcohol and another one is corresponding carboxylate, and thereby this is Canniger-Rouse reaction. And if you can go through once the Canniger-Rouse reaction mechanism, you understand that as this is simultaneous oxidation and reduction, so oxidation is involved, therefore goes with P, and there is H minus attack on the carbonyl carbon of another formaldehyde molecule. So therefore nucleophilic addition, and at the end after the hydride attack on formaldehyde we get formic acid and methoxide ion. As you know, formate ion is more stable than methoxide ion. So therefore this exchange of proton takes place. So thus we give T. Thus B goes with PRT. And for C, which is benzaldehyde reacting with KCN, alcoholic potassium cyanide, where this Cn minus will go and attack here to give this. So therefore nucleophilic attack is already there. 5 CO minus H, and this is Cn. And here this H plus migrates to this position to give 5 COH Cn, and this is the electron pair carbanion which attacks another benzaldehyde molecule. So nucleophilic attack is here. So therefore nucleophilic addition also is there, and it is an example of benzoin condensation. So thus C goes with Q and R. Then what is the final product then for this reaction, which is called benzoin condensation? It is 5 CHOH C double bond O C6H5. It's called benzoin. Therefore for C we have two answers, Q and R. For D, which is acetone dimethyl ketone you have, and methyl group is directly attached to carbonyl carbon, so it gives iodoform reaction. So therefore I2OH minus are the conditions in which iodoform reaction takes place to give yellow precipitate of CHI3. Therefore yellow precipitate of iodoform is formed, hence positive reaction for iodoform test. So it goes with S, but it also involves nucleophilic addition. So therefore also goes with R, and finally results in substitution. So therefore the answer is RST.